Hello, everybody. Again, with the absence of microphone. Boom, boom, boom. I've got like some plans for today. Oh, yeah, that's good. I should have done something else. Let me go to my file. I was worried for a second that my code was incorrect. So find main. Let's come up with a better example than this one. Something that's manifestly false. Oops. Save. And now we see it's incorrect. Interesting. Okay, so I I had worked on variable capture, but I was careless and it's not fixed. Where's this? Where does that happen? That happens in prop substitution. And I did some silly things with traversals to avoid repeating things over and over again. So prop subs. No, that's not the point. Sorry. Yeah, so subs air type. So when I subs for all, so for the y, oh, that looks quite correct. Did I mess up the term substitution? Oh. No, that's just for the free one. This subs term is here. Is y equal x, then t, otherwise u. It's annoying because it looks correct. Y prime here, and that's p prime, and p prime is supposed to have y prime instead of y, and that is supposed to be y, and that looks good. Is there a bug in my prop subs? Looks hard to get wrong. That looks great. Okay. Well, if I don't figure this out soon, we're going to just move on. I did that. I think I did that last weekend, and I was feeling confident. I'm like, yeah, I'm doing good stuff. Yeah. And my test was stupid, and I didn't see that it was stupid. What do I do wrong? Substitution works, but this one should be an X1, I think, unless my test is wrong, but I think it is. Ah, no. Okay. Okay, that's because I duplicated the thing instead of sharing it. Okay, so actually it was correct all along. Whew. I feel much better about myself. Also life. Anyway, okay, so our goal now is to be able to provide proofs for these. But we're going to do tiny steps, I think. And we're going to let the system solve the problem for themselves. So we'll just like create a basic verification procedure and check it. So for this, this is starting to be a bit of a big file. Oops, that's not what I wanted to do. Here, 4,400 lines. Sorry, in the file. It's not huge. So we know how to do type checking. We'll have to do some proving. So I'm gonna just pull up my code sectioning thing, if I can find one. And do this. Thank you. The rest. Okay, so we're gonna do. Oops. Proofs. Okay. First, we need a new type. Proved equals proved over goal. We have a goal type? Yeah, we do. I don't even know what it is. I think it's just a list of, okay, so list of hypotheses and a goal. And a proved goal as a goal that I accept has been proved. I'm kind of supposed to test for equality. So there's an equality test here. The only problem is that it's not like, so I'm going to add a warning. Danger, Mr. Robinson. Eek instance not compatible with alpha, like math alpha conversion. Okay, so it's just a stopgap. That being said, it shouldn't matter for goals because of how the point is that I don't change goals. I just want to compare goals. This is just a validation tab so that when I prove something, I can check that this is the same goal. I'm not exactly sure what the right way to do this is, but I guess I can just check at the end. But that would be quite incorrect. I need to check that. I'm not really sure, actually. Interesting. It is going to take a while. So we're going to use tactics. But for a short time, let's pull that out and take the tactics. So we have a type of tactics here that is defined in the style of Milner. And we can like it takes a goal, theorem, etc. The theorem is a type of proved goals. I've never done an actual Milner-based proof system before, and I don't know actually what the best way to represent theorems is. So basically, this is the goal that is an abstract type, So we go to proved. I guess it should be theorem. It's going to be on theorem. To do. Ow. Make abstract type. My goal at the end is to not accept a proof of something that is not the same goal. So eventually, I may actually, since theorems will construct goals. That's a better sentence. Yeah, at the end, I need to check the goal, but I need to check it for alpha conversion, probably. I'll get into trouble at some point, but let's just work for it. Okay. The first thing we can do is do theorem assumption. Takes it just takes a monet plus m and returns a tactic of goal theorem I don't want to repeat goal theorem everywhere, and it doesn't return tactic yet. It just returns an m of theorem right now. So I'll see in a second for the tactics. And theorem assumption. Actually, I need a goal for this. Okay, so I'm going to make a tactic immediately. I'll figure this out. I'll improve. Okay, we'll see how it goes. Tactic goal theorem. Tactics are very much not an abstract type, so that we can define basic tactics. So one way to do this is to be able to name I mean, it always needs a goal. I guess we can do this something like goal to theorem is the basic one, and theorem assumption of goal hips hips yada yada goal concal equals eventually hypotheses will need names, I think. Searching this by equality lm equal guard concal lm hips. So, you know, we fail if it's not correct. Something. Probably it would be better to have an actual meaningful failure. But right now we just, fail. We'll get to something useful, and then we return theorem. Theorem of G. And monet plus is not there. Okay, sorry, that's the problem. Do return. We're good. So now we can do assumption. So takes a minute plus and returns tactic of goal theorem M. This is going to be boring. Takes G equals muck muck of lambda underscore. I don't need to call anything on subgoals for it's done. And I don't know why I said G. It's just and theorem assumption. I kind of need. Oh yeah. Import. Just wishing that I haven't started Dante. Import control tactic import qualified as tactic. I could have spared some sort imports. Oh. This is true. Aha. So yeah, there's an applicative in addition. I'm just wondering what the best way to go about it is. I think I can just do compose, and I can do pure okay, so I need the G and G. It is not in scope. Yay, no more flight check error. Okay. I think I need a way to lift. Sorry. I need a generic way to lift these. Initially, I thought, oh yeah, most of these theorem construction function will be pure functions, and so I would just apply them a pure function, but I now think that this is a wrong assumption. They will be pure in F eventually, but they will have an M in front of them because all of these are allowed to fail. Uh, but I wonder. Because they shouldn't fail in the in this monad really. They should fail in they just it should not be allowed to call them incorrectly. Instead of using guard and a monad plus, I can just call error, which would actually be well. In that case, I would need to check for assumptions twice. I don't know. We will figure this out. Um, um, oh, I don't know. I was absolutely prepared. Yeah. Haven't thought about this enough. I'm rusty. It is not uncommon in Professor Ston to check things several times, which is unfortunate. Or we could just try to say that these theorem assumption things are not responsible for checking they are correct because they wouldn't be exposed and we would need to only expose the tactics. This way I can make sure that I'm testing exactly what I want and not twice. Sort of makes sense. In this particular case, it doesn't make a difference. You pass the goal and you return. Yeah, I mean, it has the right type here. It does the right thing. Yeah. I will kind of want to have something a bit more interesting than Monad Plus for error reporting, but you know. The cool thing about being abstract on the monad is that I can plug a backtracking monad and that would just work. I can do some crazy, scary thing in the background. Anyway, so what we want now is to say there is a simple tactic. A simple tactic that sort of, discharge things automatically. It needs a name. What would I call it? So the goal of this tactic is to say, okay, this is obvious enough to the type system that I will not ask you to prove it. And so I don't want to call it obvious because it might not be to the human. I'm going to call it discharge. It's a terrible name. I think for now it can satisfy some of the monad plus, but I'm gonna probably add some things to it. You'll see. I don't know why there's a T. For now, discharge equals assumption. It just searches the thingy for an assumption and then runs it. Okay. Now, I want to change the type checker a bit. I don't want it to return a list of goals, so let's go to run TCM. It returns a list of goals, but I want to return a list of goals that may or may not be approved. So if they're approved, I kind of want to remove them, but that that's not exactly what we want. What we want is just to see things. I mean, it's just like I could just remove them and just display the rest, which is sort of what will happen interactively at the end. But right now, we want to see what's happening. So what I'm going to do is I'm going to add a type here. Data. Discharge status equal discharged or open. I don't know. This is just a name. And here I'm going to return not a goal, but the pair of a goal and a discharge status, which could be a Boolean. It's just like a bit easier. To do that, we're going to do map of open apply to this. So it wants next from extension. I think I did it. But no fixer. Oh, because Dante is not on. Okay. Okay, and I need a new like PP DS goals takes like okay. So first I need a PPDS goal. PPDS goal takes a pair of a goal and a discharge status. Returns oops. And we're going to return so within the goal followed by at least a space sorry, PP goal PP discharge status goal. So right now it's I just write red bold things in the document. The better way to do that is to have some sort of more semantic things that are translated in different forms to different actual concrete values. But that's too much work right now. I don't care. So open equals, we're gonna do, let me open it. I don't know what happened. So if I'm looking for, is that check mark? No. Yeah. It's white heavy check mark. Okay, oh, that's the one I was looking for. Ballot X. I'm gonna take the heavy one. So we're going to use this for now. That's pp.plus. That's ds. Oh yeah. Then we can do pp goals. So it discharge status, pp1 goal, ppds goal. Yeah, that's good. Oh yeah, we can't see it because there's pp discharge status of discharged. So we're going to remove this and put the heavy tick mark. But there's a mark, that's good. That the heavy one? Yeah. And now I want them to be annotated with some color. pp.annotate. I'm going to do that randomly. Capital red, okay. Nope, that was not the right one. That's color. Let's have a look. Pretty printer. There's a backlink to the ANSI terminal one at the bottom. Not that one. No, 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 no. This one. And the terminal font color. Oh, it's color of something. Okay. So it's I have to fix it. Oh yeah. pp.color. Okay, now it's red. And we're going to do the same thing below, but with green. Now there's color. Okay, our goal is to check this. Is first checking the stick into a green thing. I'm going to very briefly. Make reproofs. Sorry, that was below the browser, so you didn't see anything. Okay. Now we have what we need, sort of, on the outside. Now we want to remove this, and instead, well, actually, do we? Right. We want to map. Instead of doing that, we're going to do try discharge. There. That's completely independent from the rest of the type checker. That's good. Try discharge. That takes a goal and return a goal and the discharge status. And the way this happens is try discharge equals for now this. Okay. Have a run tactic. What did I do? Prove with. Okay, so that's 0. So this prove with. Okay. So case. I'm going to change this to be for the monad to be first. I want typically to instantiate the monad explicitly. Okay. Case prove with. In this case, I don't really need to, but let's prove with maybe. My tactic is my discharge. My goal is G of. Let's go next line. So if I get just a proof P, like just proved of P of G prime, then such that G equals G prime, then this equality will be so problematic in the future. Then it is not proved, it's theorem. I should just I think I should call the constructor proved. I think I'm gonna like this, like that. So proved, then I return G together with discharged, and otherwise I return G open. Tactic. Prove with. I could have. Interesting. Yeah, because there's 0 missing. M0. Okay. So what's the problem? Oh, it's okay. Yeah. Oops. Oops. Yeah. What I do? Oh, sorry. Oh, that's not good. Okay, now it's green. Fantastic. So we can save again. A basic proof. Now I kind of want to do something more. And what I want to do is change the problem a little bit. But instead of m equals 0 here, I want to say 0 equals m. I want to go to the point where there's green again. Which is going to take time. So I want the program to reason up to equality, which we can do with congruence closure. Right now it's kind of simple because I can just like pull the congruence closure thing. Well, I kind of think that what I want is to keep track of the congruence closure context of thing in the monad. The monad that we're using. So everything will have to sort of remember if I introduce something in the context, I need to add it to the congruence closure in this monad thing. But first we just have to define congruence closures. Now we're going to just do something that slurps the entire goal instead of I'm already done a cup. Damn it. If that had fallen, I think my neighbors would not have appreciated. Okay. Apparently opening a lid is very hard. I'm still wondering whether I should have music during these things. Something nice. I don't know. It's kind of hard to find good music that I know I can have during this. I have the open Goldberg variation somewhere that I know that I'm allowed to use, but I don't know. I don't want to do like have that again every time. So we're going to talk about congruence closure. There is a package that I'm going to use to make this. It's union find. I don't know if it's on stackage. Fantastic, it is. Okay, so that's our package. We're going to have to change the cabal file. To import this as well. Oops, that's not going to work. It's building some stuff. Okay. Can I make that a bit bigger? It's going to be nicer. Woo, that's not what I wanted to do. I never remember what it is. Here we go. Yay, that's pretty good. Let's see if it stays big. So we want to add some congruence closure things. But for now, we need to do a congruence closure algorithm, because I haven't found one ready to use. I think if I were doing that in OCaml, that would have been like done. Let's have a bit of fun with this. So congruence closure, the idea. It's a pain in the butt. The idea of congruence closure is that we store equalities of every terms that appear, including the subterm, in a union find structure. And whenever we change what we do union, we also do a potential union of everything that is bigger. Every super term that we're already in the system. It's not extremely fun to write, but we'll have a look. What did I do that? Just run union find from empty. That is quite annoying. That is inconvenient. I guess I could just layer that on top of an already existing reader. No, I can't. It's just not the right abstraction for me. So I'm going to use that directly. It's a pity that it could have been useful. Okay. So, yeah, at the end of the day, we'll check if things are equivalent, if equivalent is there. There's going to be a bit of work before we can actually do this axiom. That's going to be interesting. But let's start with this. So, for congruence closure, what I need, so I'm just going to deal with expressions, terms. I've renamed expressions into terms. And you can see that in my union find, I've got something called a point. The point is basically the same thing I already have, except it's represented as an integer. That makes sense within the poem supply. So it's just like, it's a unique name for everything. So we're going to use this. But to be able to leverage this, we will need a copy of the expression data type, which is sort of annoying. And this is a place where having an unfixed data type. My keyboard is doing things. I kind of need to fix it better. That's not good. That's a good position. Here we go. Sorry. I'm talking to myself. So we will need a variant. I'll just write it down and we'll see why this could be spared. So I don't know. Let's go to superstexpr. No, actually, term subs. This will have everything that I need. Yeah. So I don't know, I'm going to call that an S term. as for shallow. Yeah, data as term equals to asvar of island or nat snat of nat of int, I think. I don't remember what it is. We'll see. Or sap. But here is not a term and a term. It's really a point term, like it's union fine point and union fine dot point. So of course nothing called union fine is around. So we're going to import data dot union find dot int map as union find. Yeah, it's not right, of course. That is not what I wanted to do. What I wanted to do was sort import. Thank you. Now we go back here into point of a term. It's a point of a term. That's 2, I think. Yeah, and we can remove it. Okay. So here it's isomorphic to a term. I can retrieve a term from there if I have a point supply, but I can, no, it's just more manipulatable. I think I will need this, basically. Not entirely sure, but I think it's unavoidable. So I'm gonna data cc for congruence closure equals there's gonna be a record. CC again, and first field is the union find. Point supply of term. Okay. We'll need more stuff. And then we need to be able to say that two S terms are congruent. So let's have a look. Congruent, take S term. It starts quickly. I already need that. Bool. And congruent S term. Congruent, sorry. UV if let's define a traversal for this. I don't have any lens library. Whoa, can't show anything. Whole of type bool, yeah, sure. That's what I expect. Let's remove this for now so that it doesn't pollute our screen. So I'm going to make a manual traversal. I'm hesitating. I think I'm just going to import lens. It's going to just take a small while, but it's going to be slightly faster. I mean, like eventually lens won't be quite the right thing, maybe. Yeah, let's just, let's not. Let's do s-term subs, applicative f, s-term to f s-term, no, sorry, point term to f point term, and these are unifying the point. Two, I'm going to put some order into this. To s-term to s-term. Yeah, I don't know why it's not properly. That's not the style I've been using. So well, that's going to be enough. Oops, I don't know what happened. S-term subs of s-var of, sorry, easier on this. No, probably we'll do all of them. So u at s-var equals pure u. That sounds sweet. Pure u. Snat also equals pure u. Term subs s app uv equals s app applied to I forgot an argument. Sorry. I think I give it a better name over there. Yeah, whatever. S app of f of u and f of v. Oops. 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 I'm gonna learn how to type someday. It's a bit disturbed by the size. Expect kind star star, but f is kind star. Oh yeah, parentheses missing. Okay, fantastic. Else term all subs. Actually, that is I'm writing this, but I don't think I need this because I need to do both of these things at the same time. Yeah, so I could do could certainly do a binary traversal. That could fail, but I think it's just going to be easier to. I'm going to leave that alone for now. I don't know if I'm going to use it, but okay, it's going to be easier to just spell this out. So s-var x and s-var. So no u, no v. Let's say y. So that x equals y, then congruent s nut. It's not very interesting, but that happened. It should be true. n is not p, where n equals p, all true. Congruent. Congruent. SAP UV SAP TS. So that actually here we can just do, it's a bit simpler, will help the system. Because that's true too. No need for guards. And we can say congruence. Oh yeah, I need a CC. Let's go to a new line. Equivalent in union file of CC of UV and equivalent in the union find of CC, that's a C, of VS, that just was very bad. What's it complaining about? I'm going to put that back into its normal size. Shit. I'm doing nonsense. Here. Okay. Because it's pretty hard to read. I will admit that today is not the best show ever. I lost my thing. Anyway, but we're going to do a full congruence closure together. I think that's going to be exciting. Pattern matching is incomplete because in other cases, then I return false because I don't have even the same shape. Yeah, one is missing. Fantastic. Okay. So it's a start. Where was I? So that's very important because when we are considering adding terms to booleans, then that happens. Okay. Sorry, what am I saying? When we're adding two terms, we need to check whether they're equal. Yeah, that's something. I'm going to have to implement merge as well. And for this, I need. Do I start with merge? Okay. Is fresh always fresh? It's always fresh. Can I check if something is already there? I'm a bit worried. Oh, that is inconvenient. So I need I need a map. Well, one thing at a time. I want to be able to merge, so I need oh gosh, points doesn't have any type class. So annoying. Okay, let's use my lib graph. I just wonder how people can use this without being able to compare points. I'm thinking. I like to avoid having to implement my own union find algorithm. We can get there, but I'd like to avoid this. I mean, honestly, if it's just for this, it's silly. Oh dear. Okay. Okay. I'm thinking. If you have things to do in chat, it's the right time. Let's see. What's my strategy? I can keep a map from like terms, OS terms to points. That's not particularly hard. But I just like lost track of what I was trying to do. I need to have a map of something to all the predecessors. The predecessors are points. It's fine. I don't need. So I need a map from points to a set of points, I guess. Could be a list, but it's hard to merge. The problem is, so that's the problem now that we're having is I just want things to be a set of points. So the fact that the point doesn't have any anything any instance on it is quite inconvenient. Because like if it had only eek, I could nub a list. I could deal. It would be slow, but it's good enough. But right now, I don't know. I don't know how to do this. And I'm extremely distracted, obviously, because I lost complete track of my train of thought. Ooh, I hope my internet is not that bad. Let me check my stream for a second. Stream seems good. Okay. wanted to go to the GitHub and see if there was any related pull requests or quick test for a map, finish sentence, fix typo. This one is old. I don't know. Is it still maintained at all? Can you derive old for point in the 30th of January? I need to use point as a key for a map. Me too. Okay. So it doesn't appear to be very maintained. 10 commits, last one on in 2012. Oh dear, oh dear. Okay, we're implementing our own union find, I guess. And I'm going to just copy this, but for the most part. Except I might not need to sort of, you know, I can only, yeah, I can generate the point by having a map from things to things. Yeah. We're going to avoid the freshness issues this way. So we're going to say, how long is this? 50 lines. It should work. We're going to kill this for a second. So union find equals union find. I'm going to end up with lenses anyway. Points is I'm sometimes typing random characters. That's interesting. Points is a map of A to int, and classes is a map, is an int map, let's say, of link A. I mean, I'll make a better one someday. And so del link, I'm just gonna take this. Deriving showing. We're going to have import data.map.strict as map. I'm going to need that soon. And import data.intMap and import data. Input qualified. I forgot to qualify at least once. If you don't put qualified, it works still. It imports qualified and unqualified at the same time. I'm very good at typing today. Okay. Okay, so we're going to implement even a union find thingy. This is completely overkill and silly, but whatever. I'm going to use the same point thing that he does. That's useful. So everything will have bad names, empty union find, because I'm not writing that in a different separate module, but it tells me a union find Vey and the empty union find equals actually I need a next as well. Equals mec next equals 0, points equal map.empty, classes equal int map.empty, and this is supposed to be classic. Ooh. Okay. Because there's already an import of data map. Yeah. Okay. That was funny. I hate import declarations. That really pains me. Anyway, point of takes a union find A, and A returns point A. Point of yeah, actually. I'm gonna make that be monadic, I think. It's gonna be helpful. I think. Yeah. I'm going to Yeah, if I do that monadically, it's going to be annoying. Or not, actually. Fair enough. I'm going to define type. Union find m equals of a equals state of union find a. So I'm going to be able to say okay. So that's going to be an A, and I'm going to do, and I'm going to do get, I think. Use get. And okay, that's not going to be very useful. I'm going to do case immediately. Case map dot lookup a in points uf of just p point p, nothing. Oh, sorry, it's not point p. It is do. Well, at least okay. Let's return point p. I'm feeling dizzy. Sorry. Not feeling super great right now. We'll try to go. We'll try to finish this though. Hopefully today, but I might sort of have to cut stream early. I hope not. So in that, if there's nothing, then let p equal next of uf. I want to put uf where next equal p plus 1 and points equal map.insert. I don't remember the order of arguments. We'll see. A, P. I'm going to have an extra constraint, but we'll fix that. In UF, not UF, in points of UF. I'm feeling weird. Hopefully it passes. Yeah, and I need to return point P. Yeah, where's this? Oh yeah, this is being annoying. Does that work? No. So one way to do this is to do convert buffer. And this should at least, I need to have Dante mode enabled. Now it doesn't even see an error. Great. Okay, I'm going to write that manually. I'm just annoyed. Okay. That's one function. Oh, and I need to insert it in the other one as well. So I don't really need this at all. I can put Mook union find. Never mind the long line. I'll deal with that later. Classes equal intmap insert so p and info 0. I don't know what this first thing is. Into classes of UF. Okay, that's quite remarkable. Then you can say wrapper takes a point A, and returns a union find M of point A. That tells me what is a canonical member of my equivalence class. I'm going to manage. So we'll call it point B do ref get and we just return that's going to be okay. So we're going to copy wrapper info as well. You know, I don't want to have to think too much. I'm going to say that it's very much inspired by. I haven't checked the license. Just let's check that I'm allowed to do this. Otherwise, I'll do my own license. BSD3. Yeah, we're good. Point N, and then we're going to do wrapper info. It's going to be just that, except we're going to do union find M of AR. And we're going to do this. Oops. So IM is intmap. As a public service announcement, don't use shorthands like this. It is so much better to just write the names like this. Right. Sorry. Okay, so here we're going to take the classes on an extra argument, whatever. We have to pass the classes here. Oops. Oh yeah, since it takes a point, I don't need to do the deconstruction here. So fine, okay. That basically follows a link, returns an info. Like returns until it finds an info and returns the thingy. It returns what? It returns KI. Oh yeah, okay, that's funny. Clever, clever. Then union. An equivalent. And then we see if we... union is a bit complicated, evidently, because of how it's the main function. So we're not going to write quite the same way. Point A, we're going to say it's a union find M of A of unit. And we're going to adapt the code accordingly. Do get, so that's UF, oh no, sorry. Oh, interesting. Yeah, okay. That is not much of a problem. Where's my type? Here. Run union find takes a union find a union find M of A returns good question. So here I'm a bit the choice is not very convenient. I don't know what that I want that to be. Well, I know what I want this to be. I want it to be union find A and A, but that's not really equals like flip run state or something. It's really not happy about this because it doesn't have the right indentation, right? Because of the do thing. Just don't. The problem here that we have is that repr info is not pure. So it returns a thingy. One way to do this is to improve on this. So I'm going to duplicate it. The other one I'm going to call reprinfo m. It's unhappy. It's not unhappy yet. Okay, I'm going to say, okay, this is a union. Find m of AR. Now it should be complaining, I think. Pretty sure it should. Let's just remove this for the time being. Right. Where is this? Oh, it's complaining about that now. Okay. Run state takes a state as a an S and returns AS, of course. Damn it. I hope I could manage to do this. It was silly. Okay, now it doesn't work because it doesn't have the right type. Ready to go. There's very little to do. And here I can do this by saying reprinfo equals if pk equals reprinfo m of p and lambda I ra to return monad, I said. Return KIRA. Fantastic. So that takes nem. Well. Okay, calm down. Okay. I am with int map because good is good. Do uf get and here we should do put now we're not showing anything to anyone except the classes, so it should be classes equal classes1. Okay, so here it's again classes of uf, that's classes1, classes1, classes2, and that is, is okay, it still works, interesting. Put, gosh, I hate this. My stream, my rules. I don't know what I'm doing. classes 2. So why am I putting this here? It is to limit the amount of vertical alignment, because vertical alignment creates stupid diffs. By stupid, I just mean that creates spurious differences that are painful for merging and for review. If I1 equals I2, then PS. What was PS? That was a return unit. Interesting. Why? Okay. I don't know why. What? I opened a DACI for some reason that told me your wish is my IO. That is mildly funny. Okay, so it says expected type unit find M, return unit find of M of unit. That means this is type unit find of M of unit, or the return type of this anyway. And I don't know why. Let's check something. Okay. Oh, I see. So that's an M as well. Okay. That was quite easy. Okay, union is done. Then we just do equivalent. Which, oops. We do monadic again. Of A. So okay. They were just looking for the representative check that they're both equal. In that case, they're equivalent. It doesn't do any path compression, which we can do with this signature, since we're always allowed to update union find when we are doing a union. But who cares? Okay, so now we can remove the dependency on union find. I'm a bit annoyed to remove these prefixes because I'm going to take the union find to another file later. I'll have to undo these. Oops. I want an exec union find a union find AR to we can do this. I think that works. I never remember exactly what it is. It's just stupid. It's not happy over there. Yeah. Yeah. Sorry for my somewhat lack of enthusiasm. I'm having fun, but I'm a bit tired. Equivalent UT. I will can do something a bit silly, but we don't need to do EE UT equivalent union find of what am I writing? Equivalent VS. It's a bit silly, but yeah. And yeah, okay. So I can remove this. In the Cabal file, I can remove this. This rebuilds everything, but it's not really needed. It takes just a bit of a while because I think the grammar generation is it's a bit of a big file, so it takes a while to build. And I'm I'm not making I'm not making any I don't remember what I was saying. But building is pretty slow for a very small grammar. There's a bit of a cost just to launch template Haskell, but I don't think that's the reason. It's just it just creates quite a bit of code. But the real problem is that I can't speak. So what I wanted was for all the reason why we did this is that, so that point could be eq and odd. Actually, yeah. Well, or we could just define a point map to be an int map, but you know. We're going to do this. So we're going to make a super term or predecessors super terms. It's a map from point term to point term. And with this, we can implement merge. We have to be careful. Sorry, from to set of point terms. And I don't think I have set yet. Right. Import set import qualified the set. Yeah, so the entire point is that we can list predecessors, but we have to be sure right. I think what I want is that everything here is want everything here to be representatives. I think we have to think how to do that properly. I need to take a break. I'll be there in a second. Hello again. That's really cool. I'm really happy that I have to play with this because I've never done this, and it's quite easy to say, okay, I can see how it works in theory. Uh, but in practice, I really have to think about the details. So, what we're going to do is the strategy for merging two terms, for declaring that two terms are equal, is let's take these two terms, merge them, then take all of their representatives, all of their of their superterms, and superterms of anything that is equal to them. Uh, Test whether they're congruent, and finally and merge them if they are congruent. Otherwise, leave them alone. And congruent is a test that we've already done. So that means that I'm not completely done yet. I don't actually. I think we need a map from point to shallow terms. Sorry. So that we can retrieve the. Is it map? I don't actually know. This is fantastic. I wish I was a bit more awake today because I would enjoy that so much more. Wow. It's so simple in principle. Like, just retrieve the thingy, test the thingy. But like doing it in practice requires a lot of care. See? Ugh. I actually yawn all the time. It's not because I'm tired. Well, maybe it is because I'm tired, but I yawn a lot. So I'm just using it as an excuse. Um, so, so do we want? I think we want our superterms to be points, because otherwise it will be very hard to keep them up to date. No, actually, it's fine because I don't test that the points are equal here. I test that they're equivalent. I think the reason why they're not like show thingy is that as I want to return up to equivalence. That would be interesting then to give May a map and a set data structure that work in this environment. So point set and point map. Um, so that I don't have to think about these. No, I just they only work within the union find M monad. This kind of fine, I guess. Um, and I need to make sure I keep them synchronized properly, but I will. And then you whenever you use them, they kind of get, I don't know, equivalentized. That sounds hard to do though. It's probably a bad idea. I don't know. Maybe it's a map that necessarily maps to a monoid so that you just something. But then you can sort of canonize the map and something like this. I don't know. But right now, we want all of these to be representatives. And so that then we can merge them. What do we have on set, by the way? Yeah, I'm sorry, I got distracted. I was reading something else. I'm in great shape. It's definitely not a functor, but it's foldable. Okay. I think I can just toList map from list, and that will do. I can actually map. Undo union. Mapment on it. Ooh, scary. Okay. Bew, bew, bew. Very slow. Oh yeah. So then the question becomes: do I want the super terms to be shallow terms? And if so, I need to be able to retrieve their points. If I do this, then I need a. So either I need, basically, that's so annoying. I have a choice, as far as I can tell. Is either I take super terms here to return shallow terms there, then I need a way to return shallow terms to their point form, or uh, or I return a point there, but I need to be able to return for each point a shallow term. Which made me think that maybe we don't want union find of term here, we want union find of shallow term. And that would make more sense. And these would be point shallow term. And we could recursively introduce a term. And let's try this actually. I think that's going somewhere. Then I can return a value. It's bidirectional anyway. I can always do this. Interesting. That's because the type here should be S term. But also the fact that I'm not using this means that I might destroy it. Yeah, I'm getting there. No, I'm excited. So I think we can do this. So the point is we want to merge in a given CC. We'll have to change the CC. Maybe we want that to be monadic as well. I haven't decided yet. 2 point. Some of these need to have shorthands. I'll I know how we can do this. I'll do that later. And that returns a new CC. Yeah, that's what it does. So getting fairly excited there. So we start with a CC. We have point pay and point, like basically their terms. So I'm going to call them C and U and V. Yeah. What we want to do is going to do CC prime. I'm going to call it CC1 actually. Or UF1 equals, no, CC. Now I want to do that monetically. There's not in containers, no. I think there's a variant that returns only the state. Eval state. Yeah, that's the one. No, exec state is the one. Okay. So the one I called exec earlier was really eval. So we can do exec flip exec state CC is do. I'm missing lens already. What is it? Modify. Modify, no. State, add state, run state, eval state, exec state, map state with state. Map state? No. Get put, it was modify. Why didn't I find it? I don't know. I couldn't find it, but that's what I wanted. So I'm gonna call this one CC0. I can use CC locally. CC to CC where union find equals I kind of need an exec as well, right? We'll ignore. I'm just going to make it a bit more type safe by saying it takes a union find A and a union find M of A and unit and returns a union find A, and this is I typed some things, and that is second. And so now it's exec union find of union find CC. Here I could really use lens. I'll probably import lens in the near future and simplify this, because that's just very lensy, very, very easy to do with a lens, or comfortable. Well, except it's easier. Let's not make like bold claims that are just not true. I should have the pure version of merge, I guess, of union. Union. It's not that bad, but I probably should. Union UV. That starts this way. Okay. But that is not enough. Because now we know that U and V are equal. But what we don't know, what we need to know now is whether it changes something for any other term. So to that effect, we need to get the superterms of both the representative of U and the representative of B. I'm going to define a function. No, I'm not going to do that. That's just too confusing, too error prone. So we're going to do so I'm going to I'm going to say that super terms st is get okay. So that just, again, I could replace that by a lens, fully be more readable. So now I've got the super terms. I want SUs is super terms is st set dot bang view. Actually, could do super terms as like parents. I don't know how to call them. The parents of U and V, the super terms of U and V. UV soups. So you want to do this. V. So that's the parents, but I also want to make sure they only talk about representatives. I'm not sure I gained a lot by using the monadic style. Representative is also yada yada. And I want to do val state. I want to do set.map. So actually, it's bad idea to do this. So I should call that CC now. So that is super term CC. I don't know how it associate super terms CC. So not the val state, it will union find. This is not very good code, but we'll get there. And find union find of CC. And I can clean that up. Just take a bit of, it will take a bit of time that I don't want to spend here. Eval union find union of what do I want to do? I wanted to do wrapper. There's a syntax issue. Okay. What's the problem? Okay. What are the lookup functions? Not set. Query. Member. Oh, that's because these are map.bang. And this is not you. This is the representative of you. Okay. Let me do something. Let repr prime equals 2. Because it's always representatives. Now, I've computed this. We want to say that we want to modify CC such that CC. I could use a put, but I feel more comfortable doing this. Union find equals not the union find. I want the super terms. To be so map.insert with set.union. So I want to insert to the new super terms to the new representative of u and v, which is either the current representative u or the current representative v. But anyway, So I'm doing that again like an idiot. Repr prime view. It's the same. Oh, that is not the right representation. Ah! Okay. That's repr 1. Okay, I need let repr 0 equal I can define it here. So these are repr 0. So this is not the same thing I'm computing, which is going to be obvious in a second. I'm not going to recompute it anyway. But so that's and repr 1 of u, which is the same as repr 1 of v. I want. I don't necessarily need all the points to be representatives, but it makes sure that I keep them to a minimum. Like that, there's no 2 points that mean the same thing in the in this map. So repr 1 of u, and then it's all dandy, but I need to do map.delete repr 0 of u in map.delete of repr 0 of v in super terms of CC. Dollar again, since I'm doing that all over. There's a missing argument. Really? What I do? So first the union, the thing, and oh, I forgot to add UV sups. So that's CC1. It doesn't make a difference which one it is, really. CC1. And now I just have to return I have to do something more. I've got to do CC2. Okay, no, that's not what I'm doing. I'm calling go here. Go of U and V. Calling them 0. Okay, I can't type. I don't exactly know why I'm messing up right now. The names are terrible. I'm gonna clean that up. So now I need to do a CC0 is get. And now that we've done that, we can go, and then we can for m underscore UV_subs dollar do I need to find all pairs, or damn it, I've got it written somewhere. Okay. Okay. I'm gonna make a single block. I think I'd love to have a point map. USIPs equals well, today there's a lot of like random typing that does stuff. Oh, that's good that I did that, because I don't think it was mapping properly anyway. So UV_subs is USIPs VSIPs. So we're gonna do for m USIPs lambda. Yeah, we'll call it a U prime, and for m VSIPs V prime, and we do I think there's when for convenience. Yeah, when congruent CC prime is get. So we do when congruent CC prime UV, no, U prime V prime, then I do go U prime V prime. Oh yeah, that is true. We don't want to do quite U prime. We want, for congruence, we want to get their shape. Yeah. So, but, actually, I think I'm wrong. So, okay. Here's the thing. I think I'm wrong. I think that I don't want these points up to equality. I really want all the super terms that exist. And yeah. So that's going to simplify things a little. I still want this to be up to equality, but this I want to be all the points. And that is kind of annoying that we have these two distinctions. But why is that? Because if I have let's think first order. So we have f of x and we have g of y, and they're both equal, or g of x and they're both equal, and then I have g of y. I don't want to compare g of y to just f of x. I also want to compare it to g of y, despite them being equal, because otherwise, the fact when I add x equals y, I miss the fact that all these things are in fact equal, and that would be wrong. So I'm pretty sure I don't need to canonize this set at all. So we're going to remove these and these. That also means that we might iterate through a ton of terms. Maybe they're not point then. Maybe they are, in fact, really, really shallow terms. That would make sense. I think that makes sense. So that's what we're going to do. I'm going to do derive ord, deriving ord. But now we need to be able to retrieve a point given an S term, which we can do by calling point of, which of course point of, which wasn't possible in the other implementation. Let point of prime equals point of in that case we know it succeeds. I'm going to improve this. I'm going to use probably some lenses. I'm going to use capability, and that's going to be so much more comfortable. I think. Let point of prime equals I'm going to make everything monadic so that we can do that fairly reasonably. The monad thing is a bit of a pain, but then it will compose well, and I think, and at the end I can remove the thing when I don't need composition anymore. We'll see, or a different kind of composition anyway. Equals point of applied to union find the CC. So these are good, and this is wrong. I think I need to do. Sorry. That would be val state No, like this, and that's so much error proneness. Variable notice scope v0. No, this one says couldn't imagine find S term with state. Oh, yeah. Oh wait, we can do this to avoid having to invent a city name. That's still not good. Oh, it was state. Oops. Okay. I don't know what I did. Okay. I can't. Oh dear. I can match S term with point S term. I thought G prime was. Huh? Oh, sorry. Let's just give it an explicit signature. Oh, sorry, that's not this. State of CC and of unit. Okay, that's fantastic. Except I don't want to do this quite because that's just way too long. I want to have an early cutoff. If these points are already equivalent, then I don't need to do this. That's somewhere here. Sorry. Go UV, where, well, equivalent is, yeah. So when not val union find union find of CC 0. This is ugly. So what do I want to evaluate? I want to evaluate equivalent UV dollar. Okay. This is ugly, but the point is, if we don't do anything, if they're already equal, otherwise we do the machinery thing. I kind of want to abstract this pattern away and do everything with capability. That will be like quite better. I would be using my my library. That's very exciting. because it's that's something I've needed. Okay, we are done. So yeah, I'll put some order into all this using capability that will make things way shorter. We'll also have to be able to add new things, but I think that's going to just follow from the types. That's going to be nice. I'm going to take the congruence closure. No, I might actually take both of these data structures out of this module because they're very generic. Oh, well, not really. The congruence closure is dedicated to terms, but at least the union find I'm going to take out, but I'm going to do that properly, and I'll explain next week what I've done. Well, next week in 2 weeks. Next week going to be video games. I'm feeling much better right now, which of course means that it's probably time to go to bed, and I'm not going to sleep tonight. But that's all fine. I'm glad to be feeling better. Yada something. What do we do next? Oh yeah, we have to put it in practice. So that means that we are going to sorry, I just thought of something. I was considering the other day having a backquote notation so that I could write times and plus, etc. in fixed notations. Which, by the way, there's still some problems about priority. So I realized that if I do that in the grammar, then I will have a different entry. I think I'm not sure, but I think it will have a different constructor than the prefix one, which is normal for a concrete syntax. But then I will have to spend some more time doing some abstract syntax things and deciding how to map abstract syntax to concrete syntax. I really want to think about this printing thing. The current situation is not particularly satisfactory. That being said, it's not really clear to me what the satisfactory situation would be. That sounds really, really hard. Writing good for the printers based on grammars. So I don't know. Yeah. So we kind of want to call congruence closure. Do this. The simplest way to do this is to add all the terms in to add everything. So right now I can like create points initially. Oh yeah, I don't have a good add term function. I'm gonna make one, but it's not going to be properly incremental. So I'm going to put a warning as well. Or maybe let's see how it goes. Add. Kind of want to move that to a module just because it's going to be annoying otherwise. So it takes a CC, a term, in terms of CC. So we're gonna have to do that as a monad again. Exec union exec state go cc0 where go as type okay. I'm feeling better, but I'm not typing better. State cc term to that term no to unit. Sorry. Go view equals to underscore. Ooh, that isn't. Wait. That was not an underscore. Okay. Good. So why am I doing that in state? I knew that a few seconds ago. Okay. So the reason for that is that I have that's funny. So here is not quite the one I want. Do I have term subs underscore? I know this one is that. This one. So I've got this function. That's kind of what I want to call. Mostly because there's no bindings, so I can ignore the bindings. So I want to call that. I want to add all the terms. Oh, that's not quite what I want. I want another one of these that is dedicated to converting to S terms, which again would be much more natural if terms would just be recursive. Next time, probably. Next time I'm probably gonna. Okay, no, next time, but soon we're going to want propositions to be normal terms, and at this point, having terms that are first order will already be over. And the reason is that so we want propositions to be terms of a particular type, so that I don't exactly know how I want to do that, but the reason for that is that I want to be able to abstract over a certain property, like to say for all order. But to be able to say that, I need order to be something I can quantify over. So it needs to be a term. If it needs to be a term, then that's it, basically. In HOL, everything is a term, but like first order term have type iota, and propositions have type omicron, and it's the only two types that are there. We have much more types, but so it will be more muddled. There's a good point about having just a iota type for terms. It's just we know that they're first order, and we can sort of work around that with that. But not there, I think. Anyway, so that's not. So we're not going to use this. We're going to use a new version that is dedicated to S term. I could have like nest term of A and something. But I don't need that right now. But I could already actually do shallow term of A, and do thingy something. For the time being, so applicative F takes a term to an F of point S term, a term returns an F of S term. Make sense? Yeah. That's going to stay that way, whatever the var x equal as pure as var x. So the entire point of S term is that this type is this. Well, it will be more complicated as soon as we have for alls, I guess. But then we'll probably have to move to some like more robust notation. I don't know how like congruence closure will be ass. We can probably ignore the for all for congruence closure, but we'll see. And equal, sorry. Of course. Modal editors are fantastically funny. Yeah, it's exactly the same function as in both. Yeah. Okay. Fair enough. Okay. So the first thing we want to do is take a term. So I want to say that u prime, there's the shallow u, I can just call it shallow u, is term shallow of go of u. That's a syntax error, but whoop. This is a good point. In fact, yeah. So this really returns a point that I ignore. Good. I'll get shallow u. So now I've added every subterm, and I want to add this one. So I want to fold all the subterms, I think. So I need to, here I'm going to look for term fold. Okay. So now we can do So that's for all a monoid a point. Oh, that's not quite the type I want. That is not quite the type I want. It's fine. I'll so what I want to do is to add shallow U as a parent to everyone in U. So that is now part of the thing. I want to add shallow U as a point. So modify lambda cc union find equal exact union find elegance. I want to a point. I need this point actually. So maybe I can't quite do this. I need this point. So I need cc1 equal get why do I do let r, that's just the final point I want to return, and I need and I have a new where am I? Help! Here! Right. I want to change the union find. So that's UF2, let's say, equals run union find of union find CC of what? Of add. That's not add. That's get point. Get point. Is that the name? Dear Lord, I don't know what I'm doing. Point of. Right. It's point of. What is the point of this? Yes, that's the question we're asking. Of course. R. No, not R. Shallow U. That would be CC1. Okay. Now I'm going to only modify the okay. I'm going to, like, you know, just for simplicity's sake, CC where union find equals UF2. So I'm going to, I think, need a function add superterm. Takes a term, a shallow term, I think I really want to do it this way. A point, shallow term, a shallow term, and returns a state CC of unit. Pretty sure. So for now, I'm not defining this. I'm just going to use it. What I want to do is, okay, you know what? Yeah, I need an iterative version that returns unit. I guess the full is fine because M of unit has a monoid, maybe. So like if I open another v term, let me type GACI. That's so if I do info of IO, I will have a monoid for IO. But is that the case for state as well? Where is state? Import control. Apparently, the telephone decided that I asked it what host meant. Trans.state. It doesn't have a monoid instance. Of course it doesn't. Like we can just, you know, it's silly. And how do we add? Well, I said wait, do that later. It is really just so that we can do this. So void. We want to s-term subs of. Let's just make it as comfortable for us as possible. And that's not the right type, is it? No. So technically, state of unit. Oops. When did I remove the space? State x of unit is nominally a monoid, but it's not exported as far as I can tell. And because of this, then we can't really use the fold function, which is a pity. This is going to realign in a second. Term subs. So I'm going to add super term shallow u to all the subterms of shallow u. So we've added everything, and now we just need to return R, I think. So this is this is I don't know yet. It would be pity not to finish, but there's still a few steps to do. So I'm not entirely sure yet that we can finish this. That's just mostly for convenience because we're going to play with equality a lot, I think, in the future. And to be able to do this, I'm just doing this. There will be a question about what to do with quotients when we get there. And I have no idea. I think the status of equality right now is a bit tricky, but anyway. Sorry. But I think it's going to be worth it. And if it isn't, we'll have had fun today, so it's fine. Add super term. I'm trying to follow. See if there's already equalities. Can I do something wrong? I get something. I get the point. I'm going to when I ask for a point, I get the sort of if it was already there, it's there. If it's not there, could it be equal to something else? Potentially. There's something iffy here for incrementality. I need to figure this out. But I'll probably fix it. It's going to be. I mean, if I have time after refactoring, it's going to be fine. So this is a do. That's my term. That's my point. I do modify where lambda cc, and I return cc where I do int. That's a map, right? Sorry. These are the parents, so super terms equals map dot insert with set dot union p p and singleton. Sorry, set singleton. U and super terms of CC. And return P just for the types. Oh, sure. Okay. that was add. So yeah, this doesn't really work incrementally. I'm pretty sure. Like if I have like x and y and x equals y and f of y is already there, and I add f of x, I need somehow to figure out that f of y exists, which I can do by going through all of these again, all the subs, and checking if like retrieving their super terms. Well, actually, I just need one, I guess. It needs to be a super term of at least one thing, and I don't exactly know what to do. I'll figure this out. I'll research it. So right now, we're going to just do that in 2 steps. Discharge. I will need traversal of all the terms in a traversal of all the terms in a many thing, actually, in everything. In types and positions. So okay. So prop terms. It's not going to go under for alls, I think. Yeah, we're not going to go under for alls. So all the terms that are immediately accessible. We should do all closed terms, so we could do something, but it's complicated. There's more to think about it, but for now we're going to do that. That means we don't go into types either, because types, they're always under binders. So applicative f term prop f prop. So prepositions. So what's interesting? The interesting is equal equals p equal. Oops, I forgot the function. F of u, f of v. Now I should have p equals, okay. Okay. So so these that have binders, so the for all, I'm just going to explicitly say equals pure p, and the rest are trivial. So I'm going to do prop terms of f and of a preposition p will be prop subs 1, 2. I'm going to ignore the thingy. prop subs underscore. Oh yeah, it has a lot of and a proposition. Is that correct? Right. So this is term to f term, and that is f. This is type to a type, and I say this is pure. This is my recursive goal, prop terms f, and this is b. Excellent. I will need something like this for goals. So goal terms. Well, I would goal, and goal terms of data goal. Just list goal, hips, conco. Forgot the f equals goal applied to traverse dot prop terms applied to f and to hips, and finally prop terms applied to f and to conco. Okay. So now I've got all the terms in my goal, and I can slurp them, and then I can add the equalities. Yes. So. It's not going to be particularly efficient. Like we may want to actually have a way to map terms to values, but yeah, it's fine. So we want to do congruence. CC plus M goal M theorem. Right now it's gonna be like this. See, we kind of want it to be monotic again. We don't have the MTCC defined. CC, MTCC. equals cc union find equal empty union find super terms map.empty. Okay. So we'll say add prime of type state cc state cc. Okay, takes a term state cc unit add prime t equals do equals no modify add t. Okay, that is not true. Okay, I'd like to finish this very late. So basically what we have to do now is like slurp everything, add the equalities, and then we have two different kinds of queries. We can have an inconsistent set, like we have some kind of, we have a negation that is supposed to be true. And that's sufficient. And otherwise, so a negated equality. Otherwise, we can query. We have an equality to prove, and this equality is already proven. And then we'll need negation introduction. I'm going to try to go as fast as I can today. Maybe we'll finish next week. It's quite fine, but I've lost a bit of time at the beginning. I was feeling dizzy and I had no idea what I was doing. And I've got friends that could have helped, but apparently they have excuses. Oh dear. Yeah. So we can do slurped. Okay. Yeah, it's not really yeah. Let slurped equal exit state. See, that's annoying, but okay, we'll deal. Exec state. Of empty cc. Yeah. And of goal terms. Add prime, so all the terms we add them. And G. Okay, so now we have all of the things. Now we want to find all of all the equalities. So we can do let learned. I really don't want to do this way, really. I'd like to, every time we could add things, like we could add equalities and terms at the same time, like interleave them, do a single pass. But right now we're doing this. Flip exec state. Not empty CC. So I slurped. And what do we want to do here? We want to do a form hips, and that's only the hypothesis this time. Lambda h when okay, case h of p equal uv. Now I kind of need to get, so in all of the case I know I'm doing nothing. Okay, that's interesting. Oh. I can ignore the other one. The other ones. Well, yeah, I kind of have to learn about the negations. I don't know what to do with them yet, actually. We want to merge to use. Going to want to add a sort of merge prime that works on terms. So what we kind of want to do is just get the point of CC, takes a CC. Well, we can use the state shape this time. Takes a term, returns a state CC point S term. I'm going to use it this way in a second. Point of CC T U will resemble the other one, equals do shallow U is obtained by doing term shallow point of CC view. Oops. And then we can just do the point val state I'll manage get eval state of a union find CC dollar point of shall you and I can do a merge prime that, you know, how is it over there? Right. So I'm going to have it in the statement as well. No, sorry. That's term CC. State CC of unit. UV equals do. U prime is point of CC of U. V prime point of CCV, and finally we do CC is get, and we do put merge CC U prime V prime. And now we can just call merge prime UV here. P equals, yeah, that was the problem all along. That in syntax. That ought to be a return. Now I finished learning. I need to ask a question. So case concal of P equals UV. For now, we can't really answer when it's not equality. So we have to say M0. When it's equality, though, we could ask the question, is the equal? Oh wait, I know kind of what to do. Are they equal? We might also want to have some more incremental versions. I can kind of finish it right now. I think. So I just need to define the is it equal thing. So it's basically equivalency CC. CC term. Term to term to states CC point state CC bool, right? That's what we want, and it's kind of easy. UV equals do. You first get the 2 points, and then I only need the parent, so I can do union find to UF get, and finally I can check return Val state is fairly awful. Union UF. No, not eval state. Eval union find. UF. Of equivalent U prime V prime. I'll see in a second. That's probably so here I can say equivalent CC of U. In, oh, sorry, no, I need to do eval state flip eval state learned equivalent CC. Yeah, that's true. That's because there should be a it should just be a Boolean. Okay. And then we can do a case okay of true, then prove G false M0. Horrible error messages. If any. Turn. Yeah, it's let. An in is missing. False. Can I even find this term? State T. Okay. We're almost there. That deserves some almost not whip anymore. Well, depending on the point of view. We don't really have a proof assistant yet, but we're getting some way there. Two tactics. Oh, okay. Oh, CC is a tactic. Again, my plan is to change the type so that CC can track goals as we modify them. But why now? We're just running CC at the very end. As a bonus step. Tactic.muck. Yeah, we don't need any subgoal. So that's the same compose pure theorem CC. CC. Wow. Where? Oh, I see. Yeah, okay. Oops. I may change this name for equality or something. Okay, but that's not quite true. Now if we're not proving an even if we're not proving an equality, actually, so so we can try interesting, inconsistent. So that what we're going to do is we're going to try with each hypothesis whether one of them is equivalent to is already like one of the negation one. So we're gonna do an any, I think. So inconsistent equal. Okay, we're gonna I'm gonna call this equiv equals equiv uv equals here we go. I'm going to need this. So if any takes the predicate, then the foldable. So the foldable is hips. If any of the hypothesis is inconsistent hip, and then a hip is inconsistent is consistent hip of pnag of p equals uv equals equivalent equiv uv inconsistent hip, otherwise that's false. So I could probably put a bit of space here, but anyway. And if any is inconsistent, it's an inconsistent hip, inconsistent yada yada. So concal true for this one, and now it's not okay, it's just concal true or inconsistent. It's not pneg. Is that p naught? Fair enough. Ooh. Oops. So we have considered a term. Okay. Uh, 610. What? Probably didn't write 610. I did. Oh, that's because it's the wrong place. Yeah, of course, it doesn't have a stack trace. But that being said, there's very few calls of this, so here we go. Yeah, that's not very helpful. It could be this one. Probably not. It's probably one of these two. So why is it not here? Oh. We only add things that have parents, not everything. So it should not be a lookup. It should be a lookup with default. What's the one? Maybe lookup with query null size member not member lookup find with default. Okay. We're not done yet. Because right now, what did you? Okay. Right now, this is not working because we are not seeing through this. So what we're going to do is we're going to do an intros tactic. That I'm probably just going to do as I'm going to do an intro tactic, I guess, and I'm going to do a repeat. So how do we do repeat? Repeat is easy. It's repeat, no, that plus m, tactical theorem, tactical theorem m to tactical theorem m, repeat, of tac is tac, it fails if the tac fails at least once. It could be 0. Okay. How do we do that properly? We do tactic.or_id. Let's try. Id. Well, no. Right. There's something wrong. I said it was easy. So if it work, I continue. Whenever it's id, it should be the end of the story. Oh yeah, here we go. So sorry, that's where the error is. So it's tac, tactic dog then, repeat tac or id. Oh. This. Okay. So now we can define intro, which we're going to do a very simple version of. Intro as a tactical theorem. Okay. We're getting somewhere. Intro equal muck. Lambda sub. Well, it's on sub. I don't know. Can do KS. I don't know. I don't know how to call that. And so there's G. Sorry. In this case, G of goal hips P naught P equal exactly. So what I want to do here is I want to call K on. What's the type of K? Let's go back to tactics. So that properly. Right, it takes a goal to a theorem, so it proves the sub goal, and so on K on goal. Okay, for now I'm going to do this. I haven't really thought about the order of hypotheses. I might want to print them in the reverse order so that it looks better. And false. I don't have false. I need this. Okay. I'm going to put P not. No, that's a bad idea. Okay, I'm going to add false. But I've got a few things that I need to fix first. Okay. So this is where this sort of thing shines. I'm almost even this could possibly be transformed into a traversal, or use a traversal to simplify some things. Pretty sure. Okay, so we added false. That's pretty good. That was fast. P false. Yeah, so have a theorem, and so we apply lambda Let me ignore the thing. It's not very good. I should check that is correct, right? Otherwise, it would let me write wrong proofs by adding a wrong tactic. Proving something true and mapping it to there. There's probably a way. So I'm going to check it. So let G prime equals in okay. I will need something to say, okay, I verified and it failed. So it's compose M0. Call this, and I want to call a pure function over it, right? That's not quite it. I can call a. It was not very convenient, but I'm gonna again. There's ways to deal with this. So what we can do is that would be get compose of so it can be compose $do. Don't need this now. Now I've got proved sub. That's subprime is get compose of k sub. Now I can do guard sub equals subprime. Maybe we want to add some logic somewhere. I'm not exactly sure. So either I give myself a way to do this easily in my tactics, which might be the right thing to do, or I do something in these. I'm pointing randomly at my screen, but the point is, either I'm doing this I'm giving myself, oh gosh, either I'm giving myself a combinator of sorts that let me do this sort of check easily, which is probably possible, exploiting the fact that compose MF uses M, expects M to be a monad, or I just have some sort of standard check inside my tactics. My tactic combinators, I don't really know. So guard sub equals subprime and return proved G. That is a good point. That is a very good point. Okay. We're going to ignore this for now because I want to finish. So we're going to say that we do k sub, and we apply lambda to proved G to it. Shit. Rewrite this again because I forgot to save it. Proved underscore. Okay. Yeah, we can write monad m at the very least. I'll figure this validation process later. There's certainly a way. Patterns are non-exhaustive. Oh yeah. What is this? Why? That's so weird. Why do I get a... I don't know. M0 in the other case. Okay, compose M0. No, then monad plus. Okay. Did I make a proof with dispatch? No. I thought I had a utility just for this compose M0 thing. Maybe I deleted it. Now we have real tactics. The tactic library can evolve a bit. I can push the library, the tactic things independently. We base on top of it. So max intros as the same type. Oops. Max intros is defined as repeat intro. Okay. And now I want to first do intros. I want to do this, or max intros tactic.then, and we're done. Okay, it is awfully late, but we're done for today. And I don't know what I'm going to do exactly next time. I think I'm starting to consider like formalizing a bit more things. We might have to add some proofs. Among other things, we might have to name axioms so that we can refer to them instead of just saying assumption. So that we can, for now, we haven't had to instantiate any axiom, but that might come. Something I'd like to look towards is formalizing lists, or maybe a bit of integer, a bit of arithmetic in lists, etc. I don't know exactly how I am going to do this, or what path I'm going to take, but we're going to start doing some stuff and see if develop some basic vocabulary that we can move on and evolve the proof assistant to something a bit more complex. At any rate, I'm going to we have congruence closure. I can push onto the branch. I think I may even consider that this is good for a commit, because there's a lot that has happened, but right now it just makes some sense. So I think I may just commit to the relevant repository on master. That will simplify my life in the future. What to do, what to say. Next week randomizer, I'm going to play a video game. It's going to be fun. There will probably be more discussions about epidemiology. I'm not sure, but since it's on everybody's mind nowadays, and I've got a book that I want to finish and read and discuss next week. And 2 weeks from now, we're coming back to that, and we're going to do some real proofs, I guess, and probably we'll have to add in some things. I'll try to refactor all this because it's a bit ugly, and figure out how to deal with validating goal. Oh, it's easy. My God, I just saw it. I can no, wait, I'm not sure. I think I think I just can call something of type m here, not just a pure function, and it will work. Because I'm going to get an m here, and I can then join. So that's fairly easy. Okay. So I can finish this. So we can validate this. Sometimes just think about something else for like 5 seconds is sufficient to solve a problem. So this is to be continued in 2 weeks, unless the word comes to an end or something. But don't hesitate to join next week. And yeah, until then, stay curious, and I'm going to close stream.